chapter 7 is looping, iteration. Iteration is the repeating of something over and over, and it's done with a control structure known as a loop. There's two different important kinds. There's the while loop. While, and I'm going to put parentheses here even though it's not necessary for the syntax. It's like an if statement, except the statements are not only done conditionally, like this is the gatekeeper to it, but the gatekeeper won't even let it out until this condition is false. So if you say while x is less than 10, it'll keep repeating this code as long as x is less than 10. If x never becomes equal or greater than 10, it'll stay in there forever, which is known as an infinite loop. So it's like an if statement that you can check out any time you want, but you can never leave. No, wait, that's Hotel California. Anyways, so it just repeats as long as the conditional clause is true. That's one of them. And then there's a more specialized one, and it comes in a couple of different formats. It's the for loop. The for loop is when you want to count through a sequence. The while loop, you can use it to count. While x is less than 10, it'll count as long as you have your x plus equals 1 in there. But that's not specifically what it's designed for. It's a generalized structure. This could be anything you want, while temperature is less than 100. Well, it's not necessarily counting temperatures. It may be hitting a sensor to find the temperature. Or, while test score is not equal to -1. You're not specifically iterating 1, 2, 3, 4, 5, 6, 7. Instead, you're letting the user type in, free-form data. Or, but a for loop is specifically designed to do counting. So for like x in range 10 will count from 0 to 9. X will equal, I don't know if y'all can see, x will equal the values 0 through 9. If we say x in range 1 to 10. Now we don't say while x is in range 1 to 10. While is just a conditional loop that it won't leave until this condition becomes true. Whereas for steps through a series of numbers. And you can, the syntax for what that series of numbers is can vary. That's one of them, the range statement. Another is that if you have a list of values, you can step through a list of values. I'm trying to remember how much of either one of those we did. Let me see if I posted notes for. Wednesday was such a long time ago. Okay, so that was the flow chart. I know we also talked about this at least a little bit. Well, I'm not really seeing it. It feels like fresh territory for me. If it's not, it's a little bit of a review, but not too much. So we've seen lots of while statements. While the two values do not match, While, our guess does not equal the secret number in our guessing game. The idea of a while loop is really easy. A for loop is just a little bit more complicated because we're dealing with a variable that is stepping one by one through a range of values, or through a series of values. So pop open yield idle. And let's make a for loop that just counts from 1 to 100. Let's make it 0 to 99 because the syntax for that is the easiest. So in idle, not in a program, don't do file new, just launch idle itself, and we're going to do it in the shell. Type for x in range, parentheses 100, print x. And then backspace so it stops indenting, and if we've got our syntax right, whoops, it'll count from 1 to 100. From 0 to 99, excuse me. The syntax for the range statement is a little bit weird, because if you give it one number like that, it starts at 0, and then it ends at 1 less than the number specified. So if you say for x in range 10, it it's going to go up to 9. If you say x in range, 200, it's going to go to 199. And the reason for that is it's kind of being rewritten inside the code. I better go ahead and start this up as a program so we can keep the notes. So saying for x in range 100 is like saying x is equal to 0. This is not valid Python. While x is less than 100, do some stuff ending in x plus equals 1. So it's less than this final number. You can also specify the starting point. This was for x, for x in range 10, so it doesn't scroll off the screen so fast. Print x, that'll print from 0 to 9. But if you want to make it start at a different number, like you want to go from 100 to 200, we could specify those values. For x in range, starting at 100, going up to 200, but we actually have to make it 201 because it stops before it reaches that last one. And then print x. I think I'll call this loopy. Hope I haven't already used that clever name. Okay, there we go. So the first one just prints 1 to 10. Yeah, well, let's scroll off real fast. The second one prints 100 to 200. So just kind of remember that you're going up one past it. So that's one kind of for statement. Another is you can give it a list of values. I'm going to change this from 100 to 110, 11, just so it won't scroll off the screen so fast. You don't have to do the same. Oh, let's do one more version of this. You see a version here that takes one parameter, one argument. You see one here that takes 2 arguments. You can also pass the range statement 3 arguments. For x in range, I want to start at 10. I want to count up to 100, so I went one past it, and I want you to increment by tens. So it's going to print 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. And there you go, 10, 20, 30, 40, 50, 60, 70, 80, 90. And if you've used another programming language like C, C++, or Java, C#, this is very similar to the syntax for int x equals 10, x is less than 101, x plus equals 10. Don't type that in unless you just feel like learning a little bit of C++ or Java there. But same syntax, just for those who have seen that, and I know that some of y'all have done programming in C. So you can see you're specifying a starting point. It's repeating while x is less than that number, and that's the number that it increases by. If you leave off that number, it starts at 0. If you leave off that number, it steps by 1. If you wanted to make it count downward, you could add a step of -1, but I'm not sure how we would actually word that in that middle part, so I'm not going to do that right now. Okay, you can also use a list of values. I'm just going to use capital L because that's easy to type for list, and a lowercase l looks like a 1. So list is equal to, and I'm going to use square braces, and I'm going to type a series of values. 10, 11, 12, 13. And there's nothing magical about x. I could call this, Fred, and as long as I used it there and there, then that would work. So for x in L, print x. What does that mean? For every list value we have, that will get copied into x. So through our first iteration, x will equal 10. For our second iteration, x will equal 11. For our third iteration, x will equal 12. For our fourth iteration, x will equal 13. Yeah, we could have done that with a range statement. So these numbers are kind of boring. Let's do a more interesting series of numbers like 21, 52, 73. Okay, you know, that's just to prove the point that it's going through this list item by item. If I have the syntax right. No, because I forgot the parentheses on X. That's the big difference. Well, one of them between Python 2 and 3. All right, there we go. And it printed out 10, 21, 52, 73. Because that was our list of values. You can add things to a list with the add command. I'm going to add a 99 and then 100 to my list of values. So L.add 99, that adds a 99 to our list, and then L.add 100. And then I'm just going to print the list without a for loop, which is totally legal. You can see the contents of the list that way. It won't be formatted one per line like it was with our for loop. But if we see it, whoopsie, list has no attribute add. Is that so? Is it append? Boy, is my face red. Let's see here. Yeah, it's append. Excuse me. Change those little adds to append. We wouldn't want the 3-letter word to work when a 6-letter word is. Okay, here we go. And so it added 99 and 100 to our list. You can also remove items from a list. You know, you can sort the list. You can do all sorts of things with lists, but this is really talking about for loops. The for loop is iterating. The text also calls it traversing. It is traversing the list line by line, item by item, element by element, copying each one into this X variable so we can do something with it. In this case, all we're doing is passing it as an argument to the print function. So if you wanted to write a sum program, well, there's an easy way to sum up a list. You just use the sum keyword. X is equal to sum, and then you pass in the list, and then print X. We'll get the sum of all those values. There we go, 355, which I'm not going to do the math, but I trust that. You can also sum a range if for some reason you wanted to do that. X is equal to the sum of the range of all the values between 1,000 and 2,000. And then print X. That is a short form of writing our own sum code with a for loop. And I'm going to write. We're going to type in the code for a sum, for iterating through a list and calculating the sum of the values, just because that's a very common computer science construct. You know, you don't always have a sum function available to you. And you can use this syntax for a great many things other than calculating sums. I did press that mighty record button, did I not? Okay. So here we go. The first thing you want to do is you want to create a variable that will hold all your values that you're tallying up. And I'm calling it tally rather than sum. Sum is a cool variable name. It's very clear. But notice that it made it purple. That's because that's a function name. And once I do something like that, I can no longer call sum_l anymore because it's no longer a function. I have redefined it. So that's bad. I don't want to erase any functions that are defined in the language. All you have to do is close the shell and reopen it, and you get your sum function back. But instead, I'm going to make it tally. Tally is not a purple word. That means it's not a function. It's totally cool to use. Now I'm going to write for every X in our list. No. Let's do that range. From 1,000 to 2,000. And I type 2001 for the reasons that have already been explained. Tally plus equals X. And then let's print the tally. I'm going to start adding words to our print statement so it's really clear which part of the program we're at. Sorry, I covered up the code. How rude. Here we go. So when I run it, that's how it calculated it with the single line of code, the sum, the nice, easy, fast way. And then here's how I did it with my loop. The reason I want you to see that is just because we want to burn in the idea of loops into our head. Looping is what computers do best. Looping is really why computers were invented, so that they could iterate and perform the same calculation over and over and over with slightly different values. All your games are looping infinitely until you exit the game. You know, you're playing Candy Crush, the program is looping, waiting for you to touch the jewels and the pieces of candy and to bring them together. Or, World of Warcraft is looping. Call of Duty is looping, waiting for your input. Looping is key to what computers do. So that's why we're spending a whole chapter talking about it, and probably more than one class period. Okay, so does that make sense how this works right there? I think that we've probably have already written code like that in this class, where we may not have used a for statement. You could write this same code with a while statement. It would look like this. I don't really care. Why did I say tally is equal to 10? That'd be pretty neat if every time you started counting something you started at 10, especially if you were talking about, your hourly wage. But there we go. You start your tally at 0, and then you add something to it, and you add something. That's why our two tallies here, our sum and our tally, did not match. Alrighty. I'll be on David Letterman with a stupid human trick. Okay, here we go. So, here's the same code written with a while loop. Tally is equal to 0. X is equal to, well, that's our starting point. While X is less than 2001, or we could make it cleaner and say X is less than 2000. Less than or equal to. But I'm following this syntax exactly. Tally plus equals X, and then X plus equals 1, because you have to increase X. If you don't increase X, you're never changing your condition. You'll never exit the loop. And then print tally. There we go. This is the same code. This is obviously a little bit groovier, huh? Because that's 3 lines of code as opposed to 5. The syntax is way cleaner. Whenever I write a while loop that's supposed to count, I always forget to put that, that very important part where we're increasing our counter. When you have something like this, you can call X the counter variable. I think there's fancier terms for it. We'll probably hit it in the text real fast. But that's just our counter. I could have used a better variable name rather than X. I could have called it counter, but I like X. We're going to leave that. Okay. You could use the sum statement like that, or you can use the sum statement to calculate, the sum of a list, which just iterates through it. Now, we had a list called capital L at one time. We probably still have it, since this is in the same code. So I'm going to print the list, and then I'm going to print the sum of the list. I'm going to precede it with the word sum just to kind of differentiate where we are. There we go. That will calculate the sum of all the values in the list after printing it. Make sure I haven't messed my syntax up. There we go. Those are the values in our list, and that's the sum of those values. As you can see, that's way cooler than writing a while loop, and it's also cooler than writing a for loop, but as I mentioned, we have to really understand looping. All right. Back to think like a computer scientist. So updating variables. This is what's known as a variable update. This is when you assign a value. You're saying, hey, you're equal to 1,000. This is updating it. It's when you use the variable's value to create a new value for it and store it back into itself. This is a shortcut for saying x is equal to x plus 1. That makes it even clearer that it's an update, right? We're taking that value, we're adding 1 to it, and we're storing it back in here. So typically you use the word update when you're talking about looping. You have some variable and you're updating it. You know, the tally is getting increased by the value of x. The value of x is being increased by 1 each time. There's a fancy word for increasing by 1, and that's known as incrementing. Subtracting 1 from a value is known as decrementing. Some languages have an increment operator, which is x plus plus. Don't type that because it's not valid Python. Same idea though, it adds 1 to the value of x. Now that's a C++ thing that became then common in a whole bunch of other languages. But I like that, but it's not that much more typing just to type that. Okay. Somebody back there is thinking, why do you keep showing us stuff that's not in this language? I can't help myself. Alrighty, so the for loop revisited. For f in, here's a series of names. Do Brad and Angelina really have kids named Joe, Zoe, Zuki, Thandi, and Paris? I don't know about that. Anyways, okay. So for f in, and here's this list, invitation is equal to, and it's creating a string called invitation so it could print it out. I'm just going to copy and paste this code. So this is a little ways down in the page. If you're on it, that's cool. You know, you don't have to type this, but I want you to at least watch it run and understand how it works. So here's a list of names. And then we're creating a variable called iteration, which is the word hi, followed by the name, followed by please come to my party on Saturday. And then it prints the invitation out. There we go. Hi Brad, hi Angelina, hi Zuki, hi Thandi. So we're iterating through this list. We're traversing through this list. We're printing out a series of invitations if they happen to be looking over our shoulder at our screen. I'm not sure if Brad and Angelina are doing that right now, but you never know. Okay. So going through all the items in a list is called traversing the list or traversal. A lot of other texts call it iterating through the list, so I'm going to keep using that word as well. But if you see the word traversing, hear the word traversing, it means the same thing. So the while statement. While this condition is true, keep repeating. Here he's written a sum function. He or she, I should not be sexist. Like I said in the beginning days, the vast majority of programmers were women. Then something weird happened. Guys took over. It's a plot. Okay, so here we go. We pass in a number into our function as a parameter. We start our counter at 1. For some reason, V is our counter. I guess V for value. And then as long as our counter is less than the maximum value specified here, add 1 to the sum, and then increment the sum by 1, and then return it. Now, if I was going to write this, I might choose different variable names. Unfortunately, max is also, well, not unfortunately because it's a great function, but it's a function name, so using max as a variable name is not the best thing possible. Otherwise, I would use the word max there, because that makes it real clear what we're doing. While x is less than or equal to the max, you know. And I'm real fond of calling my iterators I or x, so I would probably make this I or x. He used V for value, I guess. You can almost read the while statement as if it were in English. It means while y is less than or equal to n, continue executing the body of the loop. And the body of the loop is just everything that's tabbed over. Very common mistake is to tab too much stuff over. Like putting a return statement there. Well, that's going to return immediately. It's not going to go through the entire list. It's just going to print the first one. And then it's going to bail out. And that's not a dumb thing to do. It's just, you know, I'm very prone to doing it myself when I'm up here typing it. You just have to make sure that you put your return statements. You need to be conscious of what your code blocks are. That is my code block there. A return statement is not part of the code block. Here, when I was printing the tally, If I had left that tally there, it's going to print the word tally 1,000 times. That's probably not what I wanted to do. Yeah, there's a return statement there that's giving me an error. Delete that. You can't use a return statement unless you're inside a function. Okay, there it goes. Wow, why is it okay, anyways. So it tallied 1,000 different numbers. It printed every single one of them. Why? Because the print statement was inside the loop. Maybe you want that for debug purposes, but usually you don't. For one thing, the more you print, the more slowly the program runs. User input and output is always the slowest part of a program, except for possibly retrieving data from the internet or from the disk drive. You know, it's actually slower than saving data to a disk drive because it has to scroll all the data off the screen. You know, that took I don't know how many seconds to run. Let's do that. 1001, 1002, 1003, 1004, 1005, 1000. Okay, so it took almost 6 seconds to do that. Whereas if I only did it once by taking it out of the while loops code block, it sure doesn't take 6 seconds. The 6 seconds was spent in printing and scrolling off the screen. And yeah, 6 seconds isn't that long, but what if we were adding up 10,000 numbers? It'd be 60 seconds. Or 100,000 numbers, it'd be 600 seconds. You don't want to do that. I like this. This is just assuming that we're fascinated by this stuff like the author is. Let's look at a simple sequence that has fascinated and foxed mathematicians for many years. My excitement's already building. They still cannot answer even simple questions about this. The computational rule for creating the sequence is that if you start at some random number n, well, not random, I shouldn't use that word, at given number n, and then generate the next term of the sequence, I don't care. Scroll, scroll, scroll. Choosing between for and while. You use a for loop if you know before you start looping the maximum number of times that you'll need to execute. If you want to iterate through all the values of 100 to 200, you know those are the numbers I want to iterate through. So you may as well construct it as a for loop because that's a way simpler syntax than a while loop. The while loop, you have to declare your counter first, and then you have to remember to update it inside the loop body. There's lots of places you can make mistakes. So if you're traversing a list of elements, you know that the maximum number of loop iterations is all the elements in the list. You may not even know how long the list is, but the program does. I guess I would amend this then to use a for loop if you or the computer knows the maximum number of times you'll need to execute the body. So for statements like this, iterate this weather model for 10,000 cycles, search this list of words, find all prime numbers up to 10,000. You know, we know in advance that this is going to do something 1,000 times, or this is going to go through the list of words, or this is going to go up to 10,000, unless it's using some incredibly clever algorithm that lets it speed up. There are people who write dissertations on prime numbers. You know, but they're nerds. We don't care. No, I'm kidding. So by contrast, if you're required to repeat some computation until a condition is met, and you can't calculate in advance when or if this will happen, then you need a while loop. Ooh, two technical terms that I could put on an exam, but I really doubt I will. In fact, I'm pretty sure I won't. We call the first, although that's actually pretty cool, we call the first case definite iteration. Definite iteration is when you or the computer knows ahead of time some boundaries for what is needed, for how many times it will count. The later case, where it's just looping until something happens, like you enter a -1 to stop your data, we're not sure how many iterations we'll need, so that's called indefinite iteration. I think I'll just copy and paste that into this notes document. You don't have to type it, but there it is. Of course, that's just coming out of the blue. So what is this? This is when to use a for loop. Use a for loop if you, the programmer, or the language as it is running, program as it is running knows in advance how many times the loop will execute. Example, count from 10 to 100. Go through a list of names, that kind of stuff. Use a while loop if you or the program cannot predict in advance how many times the loop will execute. When we do those loops where we say type in -1 to quit, we have no idea how patient the person's going to be. If they're going to type in, 5 numbers and then a -1, or if they're going to type in 5,000. Okay, the reason I took the time to type all this in is that this is really important stuff. Just about all languages have for loops. Just about all languages have a while loop. If you go on to take any other programming classes, you're absolutely going to see these things again. So, we have seen two different versions of the while loop. We've seen the range statement, and we've seen the list, where we create a list of values. We had a list of names up here with Brad and Angelina and some other names. And we also had a list of numbers. Where did that go? There we go. Tracing a program. The idea of tracing a program is that you can look at the program and figure out what the values are going to be. And you can try to figure out if your logic is good or not. Here, that mathematical function that he wrote 7 paragraphs about, he traces it to show what happens. Well, I'm not going to trace that, but I did not mean to start Visual Studio. Let's write a function that's pretty easy to trace. I'm going to define a function called halfsies that takes a parameter n, and we're going to have a while loop. While n is greater than 1, greater than or equal to 1. You don't need the the parentheses, that's an old habit. I'm going to delete them. Print n, and then calculate n is equal to n divided by 2. So it's going to keep dividing the number by 2 until it is no longer greater than or equal to 1. Once the number is less than 1, it'll stop. And that's enough. No, I'm going to make it a little more complicated. Okay, I'm going to declare a tally variable. I'm going to call it tally. And each time we go through the loop, so above or below my print statement, I'm going to add n to the value of tally. So tally plus equals n, and then n is equal to n divided by 2. Then after it's done, I can print the tally. All right, after all that, I'm going to call halvesies. I'm going to call it with the value 8. So it'll print 8, 4, 2, 1, and then stop there if I've done this correct. There we go. 8, 4, 2, 1. And supposedly the tally of those numbers is 15. I could figure that out. 8 plus 4 is 12, plus 2 is 14, plus 1 is 15. So that worked. But we could also, quote, trace this by hand, figuring out the logic of the loop. And you do this usually only when your program is in trouble and you absolutely can't figure out what's wrong with it. And there are other ways of tracing programs too with debuggers. But we know the logic here. So we're going to say that n is equal to, I'm going to put in a different number then. Let's type, let's say that we're passing, this is going to look like a spreadsheet maybe. The value of n, the value of tally. We pass in the value 100. And then we add, tally started off as 0. And then it becomes what? It becomes 100 because we added into 100. Then we divide n by 2. So what is n now equal to? Yeah, it's equal to 50. And we add 50 to our tally. So it was 100, but it becomes 150. Then, what does n become through the next iteration? Yeah, it becomes 25. So we add, tally was equal to 100, it becomes 125. I'm going to stop writing this line of the crossouts and just put the updated value each time. So 25 divided by 2, well, if we'd done integers, let's pretend that we had done an integer division, that we had done slash slash. So 25 slash slash 2, well, 25 divided by 2 is 12.5, but if we do integer division, floor division, it just becomes 12. So tally, 12 plus 125 is 137. Then 12 slash slash 2 is 6, and we add that, we get 143. 6 slash slash 2 is 3. Add that to the tally. 3 slash slash 2 is what? 1. Yeah, it's 1, not 1.5 because it rounds down. So we add 1 to 146. And we stop because our loop said while n is greater than or equal to 1. If we had made it greater than 0, or greater than 1 rather than greater than or equal to 1, it probably would have worked. But we might have added on one last value. Okay. So I'm going to change my code to match what I was talking about. That's called a hand tracing. We figured out each step of the way. We can guess that it took 1, 2, 3, 4, 5, 6, 7 iterations. So if we ran this code, we should see 7 print statements at the end of our code. Except I didn't start with the same value. This time I said I was starting with 100. One, 2, 3, 4, 5, 6, 7. Yeah. I didn't get the same tally it did. I wonder why. 100, 150, 175, 187. Where did I mess up? 100, 150. Oh, where did I get 125 from?
You had 100 plus 25.
175. 187. This is why, well, he makes a comment here. 193, 196, and then 197. There we go. There. Now my trace actually matches reality. You can see that, we're not computers, so we make mistakes. Tracing can be a bit tedious and error-prone, which is why we have computers to do this stuff in the first place. But it is an essential skill for programmers to have. I actually don't think I'm going to give you an assignment where you have to trace something by hand, but I want you to have the concept. Counting digits. Here he's dividing by 10 each time. And the reason he's dividing by 10 each time is he's trying to figure out how long a number is. So 856. He divides by 10. You get 86 or 85.5. He probably does floor division. I didn't check. So we know that it's at least 1 digit long because this is still greater than 0. Then he divided it by 10 again. And he got 8. He He divided it by 10 again. Well, now he got, 0. So since he was able to divide it 3 times, he knows that it was 3 digits long. So that's what this is doing. Define our function named number of digits, pass into n, set our counter equal to 0. As long as n is not equal to 0, I guess that's so that it can count negative numbers as well. Your counter increases, and then you update your n value, dividing it by 10 each time. Here we're checking to see how many zeros and how many 5s are in the thing. Meh, I don't want to do that. Okay. Abbreviated statements. Incrementing a variable is so common that Python provides the abbreviated syntax for it. Count plus equals 1 is an abbreviation for count is equal to count plus 1. There's also minus equals 1. There's even times equals 1. Modulus equals whatever. So here's an example of the range statement. We've already seen that. If you see range of 10, it counts from 0 to 9. If you see range 1 to 11, it counts from 1 to 10. Range 0, 30, 5. Well, step by 5 as long as it's less than 30, so it'll print 0, 5, 10, 15, 20, and 25. Oh, here's the negative example. Start at 0 and go while it doesn't equal negative 10, subtracting 1 each time. So 0, negative 1, negative 2, negative 3, all the way out to negative 9. That one's worth throwing into our... So let's just print it out. Print range. We're going to start at negative 1. We're going to keep going until x equals negative 11, and we're going to subtract 1 from it each time. So that should count from negative 1 to negative 10. Well, that was dumb. I'm doing something seriously wrong there. Well, they're making a list out of it. That's right. Tell you what, we'll do it the way we have been doing it with the 4x in range. So I'm going to rewrite it a little bit. 4x in range, negative 1, negative 11, minus 1 each time, print x. And I forgot to put my colon at the end of my for statement. There we go. So it prints out negative 1 out to negative 10. Same idea. As long as it's not equal to negative 11, keep subtracting 1 from it each time. So I'm going to call this one count decrementing the counter. Decrementing is the opposite of incrementing. It's decreasing the value by 1 each time. And this will print negative 1, negative 2, and so on up to minus 10. One thing loops are good at is generating tables. Before computers were readily available, people had to calculate logarithms, sines, and cosines, and other mathematical functions by hand. To make that easier, mathematical books containing long tables listed the values of these functions. So if, in the 1800s, Edison didn't have a pocket calculator to figure out the sine of 45. So he'd grab his book and you'd look it up, and and it would say that the sine of 45 was equal to whatever. Creating the tables was slow and boring and tended to be full of errors. When computers appeared on the scene, one of the initial reactions was, "This is great. We can use the computers to play Call of Duty." No, actually they said, "This is great. We can use computers to generate tables, so there would be no errors." That turned out to be true mostly, but short-sighted. Soon thereafter, computers and calculators were so pervasive that the tables became obsolete. Well, almost. Anyways, here we're going to print out, yeah, let's write a loop that'll print out all the sine values between 0 and 90. Not that I remember why you use sine anymore, but we'll do this anyways. For x in range, I want to start at 0. I want to stop at 90, so I'm going to say 91. But I'm going to go ahead and give the whole syntax just because it makes me feel cool. Alrighty, so starting at 0, stopping when x, or stopping before x equals 91, adding 1 to it each time. I'm going to print the value of x out, and then I'm going to print the sine of x out. So this should be a table of sine values, except there is no sine. What is it, math.sine? Sorry. Yeah. Now, in this particular case, if we use math.sine, it's expecting the input to be in the form of radians, which, if you remember trigonometry and geometry, I don't, is different than degrees. So this is not actually doing 0 to 90 degrees. It's doing 0 to 90 radians. We would want to convert that. Really? What am I doing wrong? Do we have to import the math function?
What are you trying to find for x? Trying to find like sine of 90 or pi over 2?
Well, I mean, I'm just getting an error on the word math. Is it sine rather than sin?
Oh, I got a really cool little Dropbox that appears with things.
Oh, from math import. Okay, fine. Way up at the top of our program, we're going to import the math library. That should fix my error. There we go. And I'm sorry, you'd said.
I put my input area, my little monkey, in between math and math dot and then SIN, and it gave me a drop down where I could pick a function.
Cool. Yeah, it's doing a little bit of autofill there. So now that I've added import math, I should be able to do things like this, where it'll list all the functions in the math library. So if I say z is equal to math dot, and it didn't do it. There it goes. It took it a while, but it popped up a list of all the functions, which is pretty cool. It's taking a while, so I rarely see that box pop up. Okay, so we need to convert these degrees to radians in order for this function to be printing out values with which we're familiar with, that we would get if we pulled out our TI-30 and we typed in 90, and then hit the sine button. So there's a function in the math library for converting radians to degrees. You use math.radians and you pass in x, and it will return the number of radians that value is. So I'm going to call that r's as to distinguish it from x. R is equal to the radians value of x, and then I'm going to pass that in there. So now our code says for x in range, 0, 91, 1, r is equal to math.radians, I forgot the math dot, math.radians x. This is taking whatever our degree value is, like 45, and turning it into radians because radians is what Python wants as input to the sine function. And there we go. The sine value, I'm sorry, let me get this out of the way. The sine value of 0 is 0. That kind of rings a bell from trigonometry. The sine value of 90 is 1. That also rings a bell. So we've calculated a table of all the degrees from 0 to 90. Yeah, mathematicians in the 1800s would kill for things like that. Okay, maybe not kill. Covet. Okay. And we could do the same thing for cosine and for tangent, you know. Print out x math.sine, comma, math.cosine r. And those numbers should kind of be the inverse of each other when we run it. Well, these values are too small. The values are getting so large that they're getting kind of messed up on our screen here. But the value of sine 0 is 0. The value of cosine 0 is almost 1, or it is 1. And then if you go down to the bottom, you'll see the reverse is true at 90. Sine of 90 is 1, cosine of 90 is 0. I'm not sure if these are just absolutely inverse values of each other, you know, where you could subtract one from it and get the other. Like if it's equal to 0.999847 down here. Yeah, it is. Okay. That should be 0, but you're getting a rounding error there. That happens whenever you're doing floating point math on a computer. Floating point math is not precise, just like integer math is, because you know, it can only store so many digits in the variable, and when you do the math, or when it does the math, it'll round off. So it's a very small number. It's 6.1 times e to the negative 17, which is the same thing as 0.0 with 16 zeros before the 6. So that number, 6, don't type this in, e negative 17, is the same thing as printing 0.6, but with 16 zeros in front of it. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 13, 14, 15, 16, 17, 18. I went to 18. I said 16. There we go. So you can see that's awfully close to 0. Alrighty. So that is a table. That is a table of sines and cosines. It'd be really nice if it was, you know, formatted so that maybe to only 3 decimal places or something like that, and if it had titles up at the top, you know, to say sine and cosine. But that's, we could also print like the values of squares. Let's do the simpler syntax this time. For x in range 1, 10, 1, 11, we're going to print all the squares from 1 to 10. S is equal to x to the power of 2. And now let's print out x and s. This should give us the squares of all the values between 1 to 10. 4 squared is 16, 5 squared is 25, 9 squared is 81, 10 squared is 100. And again, these are ideal candidates for using the for statement because we know in advance, oh, I just want to print all the numbers between this specific range. Whereas, you know, doing the same thing with a while loop, the syntax would be a little bit more complicated and it would take several more lines of code. So for statements are good for when you know in advance the range of values or how many times the loop needs to execute. All right, I'm not sure if this was awesome enough to make it a hand-in assignment. But this last bit was awfully cool, wasn't it? It got your pulse pounding. So let's get that. Let's write a sum function one more time. and then we'll use this one, and then we'll use this one. So tally is equal to 0 for x in range of 1 to 100. We're going to tally all the values. Whoops, 101. And then tally plus equals x, and then we're going to print out the tally. And we're going to even be more specific. Tally of 1 to 100 is. Okay. So what I'd like for you to upload is at least these 3 loops. You could put them in a new file. So I'm going to do file loop, file new file. Paste those 3 loops in there. Save as. Sorry, I'll give that back real fast. M. When we run out of letters of the alphabet, I guess we have to stop class. Alrighty. So this is in class M with those 3 loops. All right. Refresh your Dropbox, you'll see M. You could upload the whole thing, or you could just upload the thing with the 3 files, the 3 loops. Yes, ma'am. Okay, yeah, scroll up to the top and add important math. Oh, you're right, I forgot to add that to my, my 3 loop code. Thank you. Import math.
And then on the
And we've got invalid syntax. I messed this totally up.
no, you put it.
That should be x in range. That's pretty lame when you're processing it. Okay, it's still wrong. Take the equal sign out completely. Come on. All right, so I had this loop wrong. Hopefully I have it correct now. Make sure import math is up at the top of it if you're not going to just turn in the long file that we did. And upload into Dropbox M.